present today on behalf of my team working at Linguistic Research Infrastructure at University of Zurich, where we are developing, among other things, software called VIAN-DH, which is software for multimodal data analysis, and we also include some data processing services. So VIAN-DH is a web application for multimodal corpora, and those corpora that we are dealing with include videos that can contain speech, some visual information, and also speech transcript, which is text. It is made as a part of our corpus platform, which is intended for different types of corpora, not just multimodal corpora included in VIAN-DH. And we receive different kinds of funding, but mainly we function under the funding of technology platforms at University of Zurich. And our current focus with which we are developing software is human interaction. So multimodal analysis of interaction based on videos. So to tell you a bit about the background of this research, multimodal interaction analysis is a method and a field of research that's mainly used in domains such as conversation analysis or interaction linguistics. And so far, this research is highly qualitative. These researchers, they think that in every, even a very short example of interaction, we can extract from every example of interaction, we can extract some general principles of human communication and human interaction. And they often, because of the amount of details that they extract from these short interactions, they usually work with very small samples, simply because it's very time consuming to do that on a larger scale. And what we want to do in VIAN, because we think that the information contained in this type of research is extremely valuable, we would like to scale those insights and allow for quantitative analysis of interaction. So for this, we are developing a quantitative research methodology and infrastructure to do that research. And because this has been, so far, as I said, a qualitative field, it's lacking some basic elements of a more computationally oriented domain, such as standards for data representation and database structures. Although there is software, there's different software used for this analysis. We're trying to create software that's quite focused on this type of analysis. And we are using methodology from corpus linguistics and other quantitative fields to develop querying methodology and particular analysis methodology for this type of research. And we also want to automate some of these time-consuming tasks of annotation by using state-of-the-art tools. As I already said, this what we're doing has application in conversation analysis, but also other domains such as film studies, where we have some collaborations, and also other domains across digital humanities. This is where our focus currently lies, but as I'm sure you will also see from what I present, there can be different applications to what we're doing. So when starting this work, we faced several challenges, and these are some of the main challenges. So if we work with multimodal data, just from the term itself, we're dealing with multiple formats. So we need to, each corpus needs to include different types of audio or video files, then also text if we include transcript. Text can further include some part of speech analysis or other NLP analysis, such as topic modeling and so on. Then what we also use are pose detection tools or other computer vision tools to detect gaze or nonverbal communication. And then also maybe different outputs of automatic speech recognition. And if we consider that we can add also many other types of annotation, I will just say here that the format can vary from one annotation to another. So we basically have a potentially unlimited list of formats. And then another important aspect is that we have multiple types of alignment. So if we take video files, there is the time alignment or speech transcription. So text needs to be aligned to the time axis. But if we add some annotations to text, then we also need to align those annotations to the character stream. And then further, if we annotate something that's located on the image in 2D space, or if we take the interaction as occurring in 3D space, then we also need to encode that information somehow. And then there can be different types of other additional structures layered on top of this data. So to begin with our approach to solving those challenges, we created a novel type of data representation where we created several alignment streams. We mainly currently work with time stream, which is equalized to the stream of frames in a video based on the frame rate. And we also have a parallelized text stream. And then, as you can see here, if we have, for example, a speech transcript or some tokens, each of these tokens can be aligned to the text stream based on the starting and ending index in the character stream of the corpus. But then also, it can be aligned to the time stream. So each token can have a start time and end time. We have more information such as gestures, which are only aligned to the time stream. And then we have further annotations on the text, which are aligned to the text indices. So we took this approach following, starting from the time alignment, and then we decided to kind of model text in the same way by following the continuous stream of time units, and here we have character units. And we implement this as a relational database with a pretty unorthodox method where we do not use foreign keys to link nested units, but we only have range, so we only index the beginning and the end of each segment. So for example, there is a beginning of a sentence, an ending of a sentence, and then within that sentence, each token has that information, and then if the indices of a token are contained within the indices of a sentence, it is implied that word is a part of the sentence. So we don't connect that using foreign keys. And then each segment can have multiple alignments depending on the type of information that it contains. So inside of our database, each corpus has a corpus template, which is a file specifying the structure of a corpus. And I will now cross to our interface. So this is the landing page, and I will just say that the interface was developed by Igor, who is also here today. And so you can see the visualization of the corpus template here, where we see that we have tokens, gestures, and then within gestures we have a type of a gesture, agent, or the person doing it, and for example a body part, which is whether it's done by left hand or by right hand. For tokens we have some basic part of speech tagging, and there are some other elements as well. And then here we have the viewer. This is the corpus that we use for development and testing. In the meantime, we'll have more corpora. So within the viewer, we have the the video player, and we can shift. So the video will show in a minute. This video has black. Is black at the beginning, but yeah, we can. If there are two cameras in the experiment, we can shift between those cameras, and then there are two audios. Okay, the audio doesn't go through. And then we have some navigations for playback rate, and some finer navigation by frame and so on. And here we have the timeline where annotations are presented. So there's some annotation density visualization, and then if we zoom in, we see the actual annotations. In the first line is a speech transcript and part of speech annotations. This is gesture annotation. And yeah, we can navigate through. In this viewer, we don't have the editing feature yet. And then what we also developed for this project is querying methodology and querying language. I will try to zoom in here to show this better. So our current title of the language is descriptive query language. And basically, we created the language that can be used to query different types of corpora, because we found the existing corpus querying languages to be limited. And here I will just guide you through this query. So we have a segment S, which is a sequence of tokens, where token 1 comes before token 2. Token 1 is a determiner and a noun, so for example, this book, or something like that. And then we also have the element G, which is a gesture, where the speaker or the person producing the gesture is the same as the person producing the segment S. This is a pointing gesture, and it happens within the window of plus or minus 3 seconds around this segment determiner plus noun. So just to put it in plain language, we want to look for examples of a person saying, "Could you give me that book?" and pointing to the book, or similar examples. And then if we submit that query, that takes a bit. I think the internet here is a bit slow, so it takes a while. Yeah, and so we will see here, hopefully, a preview of multimodal concordances, where we have several, because in the query input, we have several matches on several layers, for example, the speech layer and the gesture layer, and then in the concordances, we also preview those layers. So the typical keyword in context preview from text concordances is now complexified for additional layers. And then when we click on one of the results, the navigation bar takes us to that place in the video, so users can review what happens there. And okay, I'm not gonna wait for this to just find my slides back. Okay. And besides interface and querying, this is still work in progress. So what we are currently working on are automatic analysis, where we want to provide interface for automatic speech recognition. We're also training a model for gesture detection. And then we also want to allow users to run some basic grammatical part of speech annotation, and also some basic NLP tasks that they can then use to to query or categorize their data. We are working on improving the multimodal concordances, which you didn't see, but they will be even better. And yeah, we want to improve the user experience through our interface and add more corpora. So yeah, this is what I wanted to present today. Thank you for your attention.
Questions?
Yeah?
When will this be available?
This will be available by the end of the month.
Okay.
So yeah, this was the first public talk that where we presented the interface, and we're planning to release it by the end of the month.
And it's a web interface.
Yeah.
So I have to upload my videos to somewhere.
Yeah. So
No, because what if I'm like the material I'm working with is like confidential? I'm not supposed to. It's not allowed to leave the server.
yeah. So we have user management systems. So the resources that are in the database can be restricted to certain users. We don't, maybe Igor will know better, but we don't yet have the solution to use data that are located on a different server.
Yeah, right now we are storing all the data on our server, but basically I'm not sure for data should be stored in our database, but the video files can be retrieved from somewhere else. So basically that will be possible.
Yeah. So annotations need to be stored in our database following the database structure, but the other media resources can be stored elsewhere. Yeah, and maybe that's also important is that our servers are located literally at Leary. So, yeah, very local.
I have a question. How long will it take to annotate, say, 1 minute or 10 minutes? Do you have any experience of the effort that it takes?
So for gestures, we are still running some experiments, but yeah, this will definitely not be instantaneous. So this is a process which will need to happen in the background, and then we inform the user about when it is done. But basically, for a 30-minute video, this will be up to an hour and a half.
So an hour and a half for doing all the annotations by hand?
No, by hand.
Yes.
By hand, this takes, depending on what the researcher wants to annotate, this can take. For even a 2-minute interaction, this can take weeks, sometimes, because they do really extremely detailed annotations. Yeah.
Okay.
Yeah.
And what is the size then of the text of the annotations when you're for 30 minutes, let's say, or for 10 minutes? How much pages of annotations it produce?
So what we are doing here is, in order to allow for scaling of this multimodal interaction research, we need to also deconstruct annotations a bit. So the type of annotating that they do is kind of reiterative. They don't start from, they don't take a bottom-up approach where they determine an annotation scheme in advance that they will then apply to the data, but they go sequence by sequence and decide what's appropriate, and then perhaps go back and annotate the previously annotated data again, or simply not. So there's really no consistency that can be scaled in how this is currently done manually. And what we are also doing is we are trying to deconstruct those annotations to extract elements or segments that we can generalize. So for example, we just take gestures and we divide them into several types, and we annotate that. We don't annotate, for example, the speed at which the gesture is performed, the direction of the hand. There are sometimes also some annotations about the interpretation of the social context of that gesture, which we can clearly not automate. There is a lot of information which we cannot automate at all at this point, but we're trying to find the granules in this entire complex that we can scale and automate. So so to go back to your question, our automatic annotations, they're actually not so dense. So the speech transcript is like any speech transcript, which can have its own text annotations. But then gestures are sporadic, and we just have a small label for each gesture. And these are the two features that we have incorporated now. We're also have an exchange with some researchers who do more advanced automatic annotations. Okay.
Any other questions? Yeah, over there. Can you start? Yeah. Maybe Thomas. Yeah.
I can go first.
Can I choose whatever speech transcript I want, or should I use I mean, I have an idea. Can I use this one instead of?
Yeah, sure. Yeah, you can prepare also your own data, and then just we can just preview it and allow it for to be queried. Yeah.
Let's say I want to annotate some linguistic phenomena that I cannot find just by simple POS searches. Is there any possibility, any option to mark spans in the text and say this is this, like something like another annotation except POS tags or gammas, or is there something?
Yeah, we don't currently have any editing allowed in the application. So in this case, we propose combining different tools. And then we are also creating integrations of some common transcription, annotation, and other corpus management tools.
Okay, so thank you very much once again.
Thank you.